Hey, welcome to Over My Head podcast number 5. I'm Aaron Ruby.
I'm Will.
It's like locked on me, Will.
Mm-hmm.
Here, let's try that again. I'm Aaron. Wait, I'm Aaron. This is
Still Will.
nice. Okay. So hopefully that'll just automatically switch from now on. I don't know how it was locked. There we go. Okay. Cool. So what are we talking about today? First thing I want to show you guys really quickly was we talk about astro time lapses like all the time. So something that's really important for that is finding dark skies. Any light pollution that you're getting in like a sky shot is just gonna kind of, you'll see like this orange, terrible, hazy like light glow if you don't get far enough away from the city. Like I live in Los Angeles, Will's somewhere in the Bay Area, so we don't have good conditions for these things. Like right at home, we end up having to go deep in the wilderness to find what we need. So a cool site to find like good light pollution information. Let me just pull it up here. It's called Dark Sky Finder. Present to everyone. Cool. So Dark Sky Finder is just a map that you can kind of see, like a heat map of bad sky conditions. Like white is bright, and then red is bad, and it goes all the way down to blue, and then kind of these darker areas is where you want to get to. Here, let me look. So,
Like the middle of the Pacific Ocean.
I don't know if they have data on that.
Hmm.
But like, here, I can show you guys where Will and I went and did our last time lapse. It was east of Fresno. So we kind of picked a spot based on like being in this area.
And that was real dark.
It was extremely dark. Yeah, we had awesome sky conditions. We could see like the Andromeda galaxy like with our eyes. It was bonkers. I'd never seen anything like that.
Yeah, it was super cool.
So this is a good resource if you are planning a trip. You really do want to check to make sure that the spot you're heading to has dark skies if you're planning on taking night time lapses. Here, we should check near Big Sur, actually, Will,
Yeah, sure.
while we're looking at this. I have a feeling that it's going to be pretty good. Yeah, so we're going to be kind of near here, right? Los Padres National Forest.
Yeah. We might be in that blue a little bit, but on the edge there.
Oh, you think we're up here?
Yeah, I think isn't the the National Forest
Wow.
kind of wraps around Big Sur, so.
All right. Yeah, Lime Kiln State Park is saying that it's in this clear area, and then
Yep.
Ventana Wilderness is kind of in that blue, so it's not ideal, but it's pretty good. And I don't know what that is. CalStar?
Yeah, I don't know what that is either.
Must be something interesting.
Also worth noting on this topic is there's a number of like dark sky preserves in the United States.
Sure.
Not a huge number, but they're around here and again. So if you were going just to look at the sky, those are a good thing to look into too.
Mm-hmm. Sweet. Here, so I've got the link to that. It's called the Dark Sky Finder, but it has kind of a obtuse address, jshine.net/astronomy/dark_sky. So
There you go. It's just that easy.
it's just that easy. You can get there.
No trouble.
Cool. So I'll add that to the notes later.
Cool.
Sweet.
All right, so the thing we mentioned last time that we would talk a little bit about this time is a project of mine where I've been working on reverse engineering, programming a time-lapse controller I have. So let's do this and do, I guess it's just going to be easier if I share my entire screen, I think. So do you see that? You see you in tunnel vision?
Yeah, I see me and me.
All right. So I've got this Alpine Labs Radian is what it's called. Let me know, Aaron, if at any point this is no longer streaming.
It looks great.
All right. So it's this little white cylinder, and it attaches to the bottom of your camera, and it controls the camera, and it also steps it in specific amounts so that you can do time lapses. We have a silly example of a time lapse I made into a GIF that we can maybe put in the show notes that shows just what it does exactly.
Sure.
But it's a pretty cool device, and you can see here they're even pairing it with a linear dolly, which is what we spend a lot of time talking about. And this thing is programmed with an iPhone app or a web app. And let's see.
What did that say? That the Radian plays nice with others? What do they mean?
It just means that you can stick it to things. I don't think it actually has any way of syncing up, but it's just a small device that doesn't add a bunch of load to another system.
So they're just probably setting the pan device on top of something that's moving independently?
Yeah.
Okay.
Yeah, I mean, it's possible if you... I was thinking about this a little bit based off a discussion Aaron and I had offline. You could trigger the time-lapse dolly by reading when it was firing the camera. You know when it's moving based on that information. So you could design a circuit to pass that through to the camera, but also use it as a logic trigger, which is something maybe we want to consider for using them together. But that's kind of outside of the purview. Just this, what we're talking about today.
Okay.
So anyway, it's programmed with this mobile app, and the mobile app looks a lot like this. It's just a web app. You go in, you make a new time lapse, you can set how much it turns and how much time, how much it shoots, and it gives you kind of a rough estimate of what you're getting. So you can do stuff like change the rotation and the speed, and it's even set up so it can tilt the camera in addition to panning. And then when you do that and you hit this upload button, it uses your headphone jack to produce a crazy noise to upload the camera. So I'll play that off my phone so you can hear it. You hear that?
Yeah, so what is that we're hearing? This is like the code being uploaded to the Radian?
Yeah, so that's the I'm pretty sure they're just doing like a serial data transmission over the audio jack. So it's a representation of the programming as a sound, and it's very loud and nonsense, right?
It's like you haven't heard that sound since you picked up the phone in 1993 when someone was on the internet.
Yeah, basically the same deal, right? So that's cool. Like, I like that you can program it that way, but I didn't really... I mean, this interface is cool and all, but it would be cool to be able to set some stuff specifically.
And this is a computer-based interface, or is it on just on an iPhone?
This is on a computer we're looking at, but it's on an iPhone too. It's the same thing on both of them. And it's got some stuff for like bulb ramping and like speed ramping, and all this is super cool. It's just kind of lame that you have to use it in this interface.
Yeah.
To be perfectly honest. So I wanted to figure out how to program this thing without using this if I could. So in here, I just opened up the developer console for Chrome, so you can see the web page here. So in sources, if you look,
switch back to your desktop view.
I think I am on my desktop view.
I'm seeing you though.
Oh, well that's weird. Let's go back to my desktop view. How's that?
That is better.
All right. So yeah, on this web page, did you see me showing the S ramping and stuff? Then let me show that quickly. If you go in here, like it's got this
cool
fitted curve stuff.
So you can start out slow, do a fast move in the center, and then ease to a stop.
Right, and it also has this bulb ramping stuff that it supports.
And does that do any sort of like exposure checking as it's taking the pictures, or is it you set the beginning, you set the ending, and then hopefully you set it correctly?
I think you have to set the beginning and the end. So you have to.
That's pretty exciting though. I love bulb ramp shots, and I've never done one. So
yeah, it's a cool thing. So yeah, if I go into this view here, this is the Chrome Developer Console I just opened. Let's hide that so we have a little bit more room. So I wanted to look at the JavaScript to see if I could figure out where it actually turns the configuration into sound to send it. But you notice that these files are nonsense and impossible to read.
They're not formatted at all.
They're actually intentionally not formatted, hence the name Obfuscation, right? So now you're looking at this data transmission file in a text editor, right?
Okay.
So this first part up here at the top is a function that takes this string and turns it into JavaScript code on run, and then actually uses, this is the important stuff. Everything at the top is just to turn this ridiculous not code into code. So this is just a way to prevent people from reading and modifying your JavaScript code, since the source code is available. So it's normally used to protect trade secrets and stuff, but in this instance, I need to defeat this because I want to figure out how this thing works, right? So if I open this in Chrome, I don't really, like if I wanted to see what is happening when, right? Like I don't get any information. I just pause the code, right? But all it tells me is, yeah, no, we're on this line here. Cool, right? If you open it in Firefox, it actually is smart enough to figure out that that's what this is doing and turns the code into just this. And that looks something like this. Lot more readable. So what you're seeing is they're making nonsense variables and they're setting them to real properties. So, like these are the actual variable names, and then these are just to hide the fact, right?
Right. Yeah. So instead of being like interval minutes is being changed, they're like J8 has something happen to it.
Right. So in JavaScript, that would be like the thing that contains J8, J8, right? So that's not super useful. So this I've actually spent a lot of time formatting out and changing it so the words where I needed them are actually words. So like initialize, I believe I did. To data array, I think I did. So these were all these ridiculous tiny short variable names, and I made them into human readable names so I could figure out what the heck was going on. So this is my copy of this web app running off a little web server on my laptop. So if we go through, if we do a new time lapse, we just accept that that's the way it is. Where's my advanced button? It's down here somewhere.
Are these default settings that you're looking at, or?
Yeah, this is default settings. I could change them out, of course. Where is plus? There's plus. So now if we, before we upload it, I'm going to set a breakpoint. Yeah. Wait, no, not pause. In here. Sound. So what I'm interested in is it's sending, right? So let's go to data transmission, which is this file I modified. And let's see where send is, or sound maybe. I did this a couple of weeks ago, so now I gotta remember how the heck it works. Let's do this, actually.
I should just say, I have no idea what you're doing right now. This is
that's
all bonkers, crazy stuff.
Well, what I want to show, and I'm blanking on, is how I figured out what parts of the code were actually relevant when they all had their crazy names. And the way I did that is I looked at the code that ran when you hit this button, and I'm having a hard time actually. I guess I can do it.
The code that ran when you hit the upload button.
Yeah, so like if I put a breakpoint on click, which I think I can do, down breakpoints, not listen breakpoints, click, there's click, mouse, and click. So now it's going to pause when I click, right? It's going to pause at the code when I hit click. See, so now we're in this, I'm going to step to the next thing, step to the next thing. It's all in this giant gross function. Oh, that didn't work at all. Shoot. That's unfortunate. Well, anyway, what I did is I paused on that code, and it calls some function in this model.js, which is here.
Okay.
Which I believe was. And that steps through a series of these other files with all these crazy names, builds a JSON object that is going to get uploaded, sends it to the data transmission file to turn it into a byte array, and then feeds that to the sound generation wave generator that turns that byte array into a sound file and then sends it. It's just that easy, right? And it's wrapped up in all of this obfuscated code, and it's got all these magic numbers. I'm pretty sure these are related to like where the pitch is and the rate of the transmission and stuff. But outside of that, there's a lot of this that I don't really know what it does. But despite that, I was able to suss out this is how you program it. You call data transmission send with the function prepare timelapse packet and a callback that actually does the sending. So if you do that, right, you can pass it these data objects that I also dug out of the code. And this has all the settings that you can use for the time-lapse dolly. So this is the current one, this is when it was made. You can do time-lapse sequences. So this, I think, is what number in the sequence it is, how far it's going to turn, how long it's going to run, how long between shots, is clockwise. This is infinite, pretty sure. Bulb ramping, start speed, all this stuff. So you can see all these settings are in the clear now. We've figured out where to make the changes, and we know where to send them to make it actually upload. So if I do this, I've actually broken this web page enough that it won't run anymore. But if I put this code into the console, which is just what we were just looking at, the same thing, and I hit enter, did you hear that over my headphones?
Yeah, so it just uploaded those settings to an audio file.
Yeah, well, it basically uploaded them to my ears.
Right, like directly to your brain.
Yeah, to get them to actually upload to the Radian, I have to hook the Radian up to my headphone jack. But what this means is I can circumvent this application in its entirety, change any of these settings I want directly on this data object, and send it again. So that probably doesn't sound any different because whatever change it's making is super tiny, but that's the big idea. So at this point I have it all working. It's still trapped in this ridiculous web page, but I don't really know how much of this I can tear away and still have a function.
How much of a pain is it to use that web page?
It's not a huge pain, but there's some things that aren't immediately obvious how to do. So the big reason I wanted to do this is that they program it based on the amount of spin and how long you want it to run. So you can't do it starting with, I want this many shots.
Okay.
Which is kind of how my brain makes sense of it.
Is it telling you that number at the bottom, though, that it's saying it's like 360 shots?
Right, it is. So like the way that makes more sense to me, if I was going to build this interface, I would have it do number of shots and speed of turn, right? And
tell you how far that's going to turn instead of how many shots.
Right, because like if I make changes in here, it's entirely possible for me to do something like this. Oh no, you can't do that. Oh no, you can't do that. And then if I want to set it to less than an hour, I have to set this all the way up to 50, bring this down, and then I can start making it less than an hour. So there's just parts of this interface that are cumbersome, basically. So I wanted to be able to avoid it as much as I could. Okay. There is a concern, though, that I can manipulate this configuration file in ways that might not necessarily work, and I don't know what would happen. Yeah,
so if you gave it settings that the Radian couldn't handle, or there'd be no error that would say it can't do this, it would just like send it code that it's gonna fail.
And I don't know if the Radian will say this is an impossible configuration or release blue smoke. I don't know.
Yeah, exactly.
So that's obviously a concern.
I think this probably voids some sort of warranty if there is one.
And it's probably also not really appreciated. Just as another aside, when I was doing the de-obfuscating, I wrote a little script to help me with that. So that takes the garbage variables and turns them into real variables. You can see. So this just runs over these scripts and changes things out. And I was doing that ad hoc. So I probably took 2 hours just making scripts legible before I could even get to work on figuring out what was going on.
That's fascinating. I've never seen that process before.
Yeah, I might be able to show the debug process a little bit better in Firefox, just to do it. I believe it's Radian. That's right. So this is a similar sort of thing as what we were looking at in Chrome. So you see what I mentioned when I hit this button. Firefox is smart enough to figure out that that code was obfuscated and turn it into something legible, which is pretty rad. And now if I do...
So you just fed it that one single line of code and it put breaks in it, and or those breaks already like encoded in there somehow? It's just...
Yeah, those breaks are encoded in there, but the Firefox debugger is smart enough to show me the actual code instead of the evaled code. Like this router file is still wrapped in this code block that turns it from a string into actual code. And Firefox is actually showing me the real code, which is pretty cool. So let's go through this again. Click on this invisible arrow, because I didn't download the image for it. And then do a...
Is the Radian kind of listening all the time for new directions?
Yeah, when it's running after it does its initial startup configure, it is able to hear you at any time. And then once it gets new directions, it does a calibration step and starts right then. And it also starts up immediately on, turn off. So if you have a setting in it, you don't need to refigure it out.
So what are the chances of you being able to learn the Radian's language to a point where you could just do like a little and then it would know what you wanted to do?
I'm pretty sure I wouldn't be able to modulate fast enough, unfortunately. So I just put a little breakpoint in here and in this timelapse upload function. So I'm going to click upload. And it is going to be super mad at me and not run. Is it already paused? No. Why is this not working? Well, that's a shame. I don't even want to show that.
The idea is that you're trying to, that function will run, but its first line it'll stop.
Yeah, it'll pause, and then you can control the running of it.
Because you can like look at the code that's actively running and change it.
Yeah, because JavaScript is so crazy and is continuously editable in real time. Yeah, you can do that. So you can see like this code even looks different in Chrome. So I don't have that line to put a breakpoint on because I'm seeing the actual obfuscated code instead of the running code. Unfortunately, I don't think I'm going to be able to get this thing to pause on update.
Typing's tough.
Yeah, turns out.
It's hard to do it with millions of eyes watching you.
Yeah, fortunately I don't have that problem.
Yeah.
Yeah, so anyway, that's the basic idea. I don't know that I'm going to be able to get this thing to work, unfortunately, to show the other thing off, but that's all right.
That's okay. I think that that Radian is really capable. I'm interested to start playing with it.
Yeah, it's a nice piece of hardware. It's really just it does one thing and it does it really well. So like really consistent step size. Yeah, pretty good, pretty excellent.
So it has a stepper motor inside of it too. Do you think, or?
Yeah, there's even pictures on their site of one with its guts exposed. It's a heavily geared stepper motor, so it's got a lot of torque.
A lot of torque.
Yeah. And we were even talking about using it possibly as a drive on a line time-lapse dolly, similar to what we talked about last time, which might work. I'm not sure yet. It's a little bit. It's definitely not the intended use case.
But if it has a lot of torque in the package, though, you could probably make it happen.
Yeah, I think it might be possible.
Harness that spin. Then you'd have to come up with new ways of thinking about spinning as linear length.
Yeah. Yeah, and unfortunately, the way they conceptualize that programming just doesn't track with the way I would think about it. Obviously, they're coming at it from the duration of the clip you want, which I think does make sense. But for us, at least, it's not certain that we know that when we're going it. It's like, oh, we're going to let this run, and if it's cool for the length of it, we'll use it. So yeah, it's definitely a nice piece of kit. I'm excited to get to use it for real. I haven't had an opportunity to take it out.
Cool.
And yeah, just to come back for a second, that to get it to sync up with the time-lapse dolly isn't something it supports, obviously, but I think there might be some ways to do that, because the dolly obviously moves and stops, moves and stops. The Radian also moves and stops, moves and stops, moves and stops. So those two things need to line up.
Right, and it seems like that would be pretty simple, but my worry is that the time-lapse dolly, the amount of time it stops each time, there might be like half a second or a second of play in that number, because I don't think it's very accurate.
Right. Well, and also...
or it might just be that it counts 30 seconds longer than the Radian counts 30 seconds.
Right. Yeah, so the Radian, I think, has a crystal in it, so it has a pretty accurate timing circuit. But the Arduino out of the box doesn't. So we could hook up a more accurate timing circuit to an Arduino. Right. But I think what we might be able to do is jury rig a system where the camera shutter also informs the Arduino that, hey, we're stopping.
So maybe like when the camera opens, the Arduino stops moving, or something like that. Is what you're saying?
Well, more that when that shutter's released, start the clock. So you don't have to be synced for the whole run. You just have to be synced for the shutter.
No, that would be good too, because we have those like overflow problems with just trying to keep continuous time counting.
Right. So basically, allowing
that'd be sweet.
Yeah, allowing the Radian to be the timer, which we'd have to gin up some sort of circuit to listen to that camera port and pass it on to the camera. But I think it's possible.
Well, we send that signal to the camera, right, to go?
We do right now, yeah. All we got to do is listen to the Radian, I think.
So. Oh, I see. You want to use the Radian's camera control.
Yeah, so the Radian moves, and it fires the camera. But the Arduino also listens to that camera firing, so it knows when the camera's done, so it knows it can move.
Yeah, and you don't mean that it has a microphone on it and actually hears it firing, but you're saying there's a signal somewhere that we can intercept.
We split the camera control, yeah.
Oh yeah, that makes sense.
So it's something to think about, anyway.
That would be cool, for sure. Who knows?
All these things.
You can pull that off.
Yeah. It's the jack on it is just a 3.5 millimeter headphone jack, so it's a pretty normal thing.
I was wondering, how does the Radian accomplish bulb ramping? Is it just adjusting shutter speed?
Yeah.
What's its connection to the camera? Is it just the normal
bulb? Yeah. So it's got a headphone jack to an N3 connector that plugs into the camera. And then, yeah, it just controls exposure.
And that's 3.5 on that side?
Yep.
Oh, the ones I have are 2.5.
I think it's 3.5. It may be 2.5, but I think it's a custom cable.
Okay. Cool. I wonder where they found N3 connectors, because I tried to find like a source for those, but no one has them.
Yeah.
Except
these guys were
factory.
These Alpine Labs guys were kickstarted out of Palo Alto, I think. So they're relatively local. They've been used on a lot of cool stuff like this project, Yosemite. So pretty similar sort of idea.
Are you showing us something?
No, I was just looking at their website.
Oh, okay. What's it called? Project Yosemite?
Project Yosemite, yeah, use these. And the BBC has them. There's another one called Astro. That's pretty similar, but instead of being programmed by a computer, it's got physical controls, which is kind of nice. in the event that your physical computer or phone is dead.
Wow.
They're pretty much break even.
Yeah, this is gorgeous stuff on Project Yosemite.
Yeah, it's a really nice piece of kit, so it should be cool.
And that's just a Radian and 5D or something that they're out backpacking with?
Yeah. That's the other thing that's nice about it, is it's a relatively small unit. I can actually grab it and show it.
Yeah, that's sweet. Let me show that website for a second here, since we mentioned it. Yeah. I haven't seen this website. Have you known about this for a while, or is it they brag about it on the Radian website, probably?
Yeah. Yeah, they do.
That's gorgeous.
Yeah. Yeah, is that Glacier Point or something? Somewhere up high.
Mm-hmm.
That's that orange glow Aaron is talking about, probably.
Yeah, right. So in Yosemite, you're in a pretty dark area, which is why the skies directly above are nice and clear. You're seeing the Milky Way, but this is probably looking east towards the Central Valley.
Yeah.
And you can just see all of the glow from the cities out that way. Yeah, that's cool. Really, really cool stuff.
Yeah.
I think something we do need to talk about one of these episodes, Will, is a little bit of workflow for after. So, like, you take a bunch of shots and then sticking them together into a motion time lapse.
Yeah.
Taking them through Lightroom, giving them like a look, and then sticking them together.
Yeah, absolutely.
Because you can kind of see that these have been color corrected, and I wonder if they color corrected in Lightroom on like an individual image basis, or if they stuck the video together and then
did it in speed rate or something.
I feel like if you're shooting raw, you would want to color correct at that stage when the raw information is there instead of in a compressed.
Yeah, I bet they probably do a pass on either end.
They must do something.
This is the actual unit that we're discussing. So you can see it's not very large.
Large hockey puck.
Yeah, this is my phone next to it. So it's pretty light. It's pretty solid construction. There's a little bit of play that it corrects for when it's actually turned on.
Yeah, where's the spin?
If I turn it on, it's the top and bottom are separate pieces.
All right.
So if I turn it on here, it'll do a little calibration step. So wake up. It's going to spin. Beep, spinning. So that was calibrating, and now it's going to run whatever time-lapse we programmed into it last.
What's the calibration step?
It's to correct for that play. So it's figuring out. Yeah, it's moving in my hand a little bit.
I wonder if it's just like finding a spot where it's on a full step to start from a good place.
That could be. The documentation on their site says it's for correcting the like wind blowing and stuff. They got like a known step size. So yeah, you just slap your camera onto that thing and you're good to go. It's got a tripod.
How long have those guys been doing this project? Like, they did Kickstarter a year ago, 2 years ago?
Yeah, a year and a half, 2, I think.
And then before that, they must have been trying to figure these problems out for years.
Yeah, I mean, they were probably doing. They have an over my head podcast from 5 or 6 years ago.
Yeah, I'm sure they had the name first.
Yeah.
That code base is pretty steep, though. Like, what do you think is the microcontroller that they're using?
That's a good question. I know that the original prototypes from the Kickstarter has a lot of the background information on this device. I think they used rapid prototyping sort of tools, 3D printing and stuff. Now these are being manufactured properly. So it might even be something custom.
A custom controller, you think?
Yeah.
That'd be cool.
I mean, it would probably be some sort of standard chip, like an Amiga or something, but it probably isn't running.
Not like an Arduino board inside of that thing.
Yeah, and it's really solid. I mean,
I think that's what they do.
Heavy
like the Emodemo is they still have like an Arduino inside of there somewhere.
Yeah, that could be. I'm not sure. There's no real way to interface with the programmer that I know of. I know you can do firmware updates over the USB port, but who knows what kind of protocol. that thing speaks. So.
Cool. That's awesome. So thanks for showing us that debugging. I still don't quite understand how you're getting at that code. Is that coming from like a GitHub repository, or
no. So in order to run the code, your computer needs to have it, right?
Okay.
So when you download the web page, it lists all the scripts it needs. So they all come over, which is why they need
saving a copy of their web page, and that's how you're getting it.
Yeah, so that's why it's obfuscated, right? Because everyone needs to have a copy that runs, but they don't want everyone to have a copy that they can edit. Which I think is kind of silly, because all that you could do if you edited it was program their time-lapse dolly.
Or package it as your own time-lapse dolly, whatever, and sell it.
Yeah, but it would only work with their hardware. So.
Yeah, I don't know. I'm sure someone spent a lot of time on it. Is probably why they wanted to do that.
Yeah, and it is sort of industry standard practice for that. But
yeah.
It would be cool if I was able to have a safety protected way of just dumping raw configuration files.
There's that code. What code is checking that though? Like you've got to be able to.
So the UI doesn't let you put invalid configurations in, but it does check for some cases, like if it would be going too fast or that kind of thing. So I could figure out what checks they're doing there and replicate them. But there's some things that it would be impossible to make the settings look like if you're using the UI that would be easy to do if you're using the text. That they wouldn't need to check for. So I don't think there is a faculty for that. And I'm not sure how robust this thing is to not get bricked by putting a bad configuration.
So you're saying that there's just not some values in the UI, so you wouldn't be able to send like certain...
Yeah, like it won't let you turn on, I don't know, bulb ramping and one of the other settings to some extreme values, because it's nonsense, basically. But the text doesn't have any ability to know that.
Cool. Cool. That was awesome.
Well, cool. There's all these text files.
All right, well, come back next week. We'll be talking more about astro time-lapses and all the problems that come along with that. This has been Over My Head number 5. See you guys later.
Peace.